function in there as a piece of our piecewise function. Now, I showed you the first time, I showed you how to build a table. Okay, this time I'm going to show you a different approach. You pick whichever one works best for you. Y'all seem to be getting pretty well with the table, but like I said, I just want to show you a different perspective. It changes, this function changes at 4. So what I'm going to do is at x equals 4, I'm going to put just a light dotted vertical line so that I have that visual representation there to show myself that this side of the function, when x is less than 4, my function's going to be negative 2x plus 1. When x is greater than or equal to 4, that's the right side, I use the absolute value function. And I write those inequalities above the two pieces so that I can see, okay, this part to the left of this line, I use the x less than 4, so I use the negative 2x plus 1. Because that's a line, we can graph a line, right, if we know the y-intercept and the slope. So what's the y-intercept? 1, right? Positive 1. I can use that in this case because the y-axis is on this half of the graph. Okay, I can use that because the y-axis is on this half of the graph. So then I just use my slope of negative 2, right? So I'm going to go down to right 1 until I get ready to run into my line. This part does not have the equal to, so when I get to this x equals 4, where that next point would be, I'm going to put an open circle. And I can keep going in the other direction if I want to, just to make my graph complete. Go all the way up there to the edge, and then connect my points to produce my line. There's the left side of my graph. Okay, now the right side, I start at 4. So I'm going to start by plugging 4 into my equation. 4 minus 3 is 1. Absolute value of 1 is 1. So 4, 1 gets that point right there because it's equal to 4. This piece has the equal to. Based on what we learned about the absolute value function yesterday, we know that it has this one, because there's nothing in front of the x, it just has a slope of 1. So we can go up 1 over 1. Or we can keep on plugging in the x values. You plug in 5, you get 2. Plug in 6, you get 3. Plug in 7, you get 4. Plug in 8, you get 5, so forth and so on. Okay, so this piecewise function has an absolute value function part to it. It doesn't look like it. It just looks like another line. Why do we not see that v part of the absolute value? Can anybody tell me why we don't see the vertex part of the absolute value function? Well, no, it's not continuous. Okay, but that's... Why do we know? Why does this piece, the absolute value piece over here, why does it not look like an absolute value function? Where's the vertex located? What did we learn yesterday? Where's the vertex? Positive 3. Positive 3 is not part of this part of the function. We start at 4, so we're just missing the vertex. It's still there. It's just not showing up because of where this piecewise function changes. Okay. So the vertex is still at 3, but that part of the function doesn't apply until we get to 4. So that's why we don't see the full shape of the absolute value. The domain of this is all real numbers, okay, because we've got less than 4 and then greater than or equal to 4, so we hit them all. How about the range? Y is greater than negative 7. Y is greater than negative 7. It doesn't have the equal to, because this point down here is an open circle. So we don't actually equal negative 7, but we get really, really, really close to it. So it's anything that's greater than negative 7. All right, so let's do number 8 kind of the same way. We're going to split it up. This time we have 2 places to split it up. At x equals negative 3, not being very accurate here. Okay, and at 2, positive 2. So we've got x is less than or equal to negative 3 over here. We're between negative 3 and 2 here in the middle. And we are greater than or equal to 2 on the right. All right. So we've got another absolute value function. Yesterday we started by graphing the vertex. What's the vertex of this absolute value function? 0. 2x is equal to 0, so x equals 0. Well, that's outside of where we're supposed to be graphing this. So the vertex isn't going to help us out. So if I'm doing this completely by hand without a calculator, I'm just going to start on the far left side of my graph. Okay, this goes all the way to -8. So I'm going to plug in -8. 2 times -8 is -16. Absolute value of -16 is +16. 16 minus 4 is 12. 12 is off of our grid. So I got to pick another one. Let's go to -7. That gives us 14 minus 4, that's 10. Still off of our chart. Let's look at -6. 2 times -6, -12. Absolute value is +12. 12 minus 4 is 8. We can finally plot a point fits within the grid that we've got here. So -6, +8. When we plug in -5, excuse me, we get 10 minus 4, which is 6. When we plug in -4, we get 8 minus 4, which is 4. We plug in -3 because it's equal to, so we get 6 minus 4, which is 2. So once again, it's got an absolute value piece. We just don't see that V to it because the vertex is not in this piece. Okay, between -3 and 2, our y value is always -5. But it's not equal to -3 and it's not equal to 2, so we've got open circles on each end there. Okay, and then when we're greater than or equal to 2, we've got the line x minus 2. Well, we can't use the y-intercept here because the y-axis is not in this part of the function. So we'll just start with 2. Okay, 2 minus 2 is 0, and it's equal to, so we put a point. 3 would be 1, 4 would be 2. Okay, we got a slope of 1, right? So we just go up 1 over 1 from that point. And that is that piece. Okay, so it's up to you. If you like making a table using your calculator, that is perfectly fine. To split it up, you're essentially doing the same thing. Okay, when you make the table and you put -3 above a line, below a line, and then when you put 2 above and below a line, you're doing the same thing. Okay, I'm just skipping the table part of it and doing the arithmetic in my head. Okay, so whichever method works best for you, just make sure, please make sure that it passes the vertical line test. None of these lines should be crossing over each other. So when you move left to right, you're only touching one point of the graph at all times. Okay? And technically these dashed lines right here, the dashed vertical lines, are not part of the graph. It's just that visual to show you where to split things up. Okay? All right.